MTA Networking Fundamentals, IPv4, Subnetting. I will be honest with you, it is not an easy topic. I was really surprised a few years ago when I started teaching MTA Networking Fundamentals for the first time. I was really surprised that Microsoft decided to add that topic, and I'm very happy they did that because, you know, I do the same. I like to introduce subnetting straight away because you need time. That's all I have to say. In a few minutes, when we go through our first example, I can guarantee that you will not understand 100%. And it's not that I'm a bad teacher. I hope I'm not. It is something that, you know, you just need some time, if you know what I mean. If, let's say in 5 minutes or 10 minutes, if you say, yeah, kinda, yeah, maybe, that's all I need. Okay, you have to watch it again, watch some other lectures. There is a really nice document that I prepared for you with everything that you have to know about subnetting, even, you know, more advanced topics that are not in MTA. I decided to include everything so you can read and, you know, just learn more about subnetting. Why not? Let's get started. Ready? Let's start with a very simple example. I was given 192.168.1.0/24. I was given an IP address like that. Now the first thing we have to discuss and explain is this number. What is /24? Because it's like, okay, I know some subnet masks, okay, I know it's 255.255.255.0, it's just an example, but what is this 24? Now I want you to focus. 24, it is the number of bits in your subnet mask, the number of ones in your subnet mask. And you all go, what do you mean? Here we go. 24 ones. Let me do that for you. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is in binary. If you convert all these numbers back to decimal, you will get 255.255.255.0. Now, not sure if you know how to convert to binary. If you do not remember how to do that, we'll go through one example to make sure that you know how to do that. When we just do subnetting in a few moments, I'll show you how you can do that. Does that make sense? Okay, 24 ones. Okay, 8, 8, 8, 24 ones. I hope you're okay with that. Let's move on. Now, you have the following question. 192.168.1.0/24. Now, they told you the following thing. Can you be so nice and divide this network into 5 sub-networks? What does it mean? Unfortunately, that's what I mentioned. We do not have enough IP addresses. The same applies to private IP addresses. You can think, oh yeah, we have, you know, thousands, millions of IP addresses. Well, there are companies that need more than that, and you can't just assign a network here and there. For instance, if you just need a point-to-point connection, just imagine you have 2 routers and they're connected to each other. How many IP addresses will I need? Yeah, 2. 1, 2. That's it. Is it possible I will need more than that? Not really. For a point-to-point connection, I will just need 2 IP addresses. How many IP addresses can I get in a network like that? Do you remember? 0 is network. Yeah, we start with 1. What is the last IP address? The last IP address is 254. Usable IP address. And 255 is a broadcast address. Broadcast address. Okay, broadcast means that I want to send a message to everybody. It means I am not allowed to use the first one, which is my network address, and the last one, which is my broadcast address. So I will ask again, how many usable IP addresses will I get? 254. How many do I need? Well, I need 2 IP addresses, so I am going to use 2 IP addresses, and 254 are available. It's not a good thing, we don't do it like that. Let's go back to our example. I know I need 5 sub-networks. Subnetting is easy. Well, I said it was difficult. What I mean by that is it is easy because you just have to follow a few steps, and every time it is the same. That's why the key is to do it again, and over again. And then if you're tired and you said, no, I don't want to do subnetting anymore, do it again and again and again. Okay, the first thing you have to do, you have to convert the number of networks you need into binary. It means I have to convert number 5 to binary. 5 to binary. That's what I have to do. Not sure if you remember how you can do that. I will, just in case, I'll show it to you. We start with a table. 128, 64, 32, 16, 8, 4, 2, and 1. That is a table that you will use every time you do subnetting. If you're interested, it is 2 to the power of 0, 1, 2, and so on, yeah? Let me just remove it. Okay. Now, we have to convert number 5, okay? We look at this table and we say, no, 128, that's not good, it's 0. 0, 0, 0, 8, no, that's too much. 4, yeah, that's okay. Because 5 minus 4, I can do that. It is 1. I am left with 1. 2, no, that's not good. And 1, yeah, I'm okay. 1 minus 1, that's okay. You should always get 0 at the end. It means that 5 in binary, it is 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Yep. That is 5 in binary. Okay. If you're not sure, just do it again. Make sure that you're comfortable with that, because that is something you will need. The second thing we have to do, we have to convert the original subnet mask to binary. 24. We know how to do that. 24 means we have 24 ones. Yeah? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That was easy. Now a question. How many bits do I really need to get number 5? Do I need 8 bits? No, I need 3 bits. Why? Well, you can skip the zeros. Why? Let's say you owe me £100. If I tell you, you owe me like that, is it still £100? Yes, it is. That's why we need 3 bits, at least 3 bits, to get number 5. It has been easy so far, to be honest. Now it is the tricky part. You have to memorize how to do that. When you look at the original subnet mask, you are not allowed to touch anything with 1 inside, because 1 is network and 0 is host. Okay? You're not allowed to touch anything with 1 inside. It means you're not allowed to touch the first 3 octets. It means they're not going to change. Now you have to take 3 bits from the last octet, because it's the only place that is available for you. How are we going to do that? We'll just do it like this. 1, 2, 3, 4, 5, 6, 7, 8. So the new subnet mask is 1, 2, 3, 4, 5, 6, 7, 8. It doesn't change. 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now if I ask you to write it like that, what is it? /20? You have to count all ones, so it's 24, 25, 6, 27. Okay, our new subnet mask is /27. That is our new subnet mask. If you want to write it, that is in binary. If you want to write it 255, 255, 255 dots, now you have to convert this number back to decimal. It's in binary, 1, 2, 3. And then you go back to this table, 1, 2, 3, 4, 5, 6, 7, 8. And then you have to add all numbers. 128 plus 64 plus 32. Okay, does that make sense so far? Let me remove a few things from the screen and we'll continue. Okay, I am ready. So let's summarize what we have calculated so far. We know our new subnet mask is /27 and we know we need 3 bits. Okay, that's good. That's a lot. Now the last step. We have to create our ranges. What does it mean? They asked for 5 subnetworks. It means that we have to create 5 subnetworks. We need an increment. We need something that will allow us to make it happen. We need a number. Is it like 192.168.1.0, then it's .10, .20, so the increment is 10? What is it? We don't know. And now again, a tricky part. The increment is the last digit in your subnet mask. Then you go back to this table and you check it. So it is 1, 2, 3. That is your increment. 3 bits, right? 1, 2, 3. Our increment is 32. That is your increment. It means our ranges are 192.168.1.0. Then you don't fill the right hand side, just go below 192.168.1. Our increment is 32. Dot 64. Dot. If you set 128, it's not correct. Increment is 32. 96. Just be honest, did you say 128? I'm pretty sure you did. Most people don't say it. Okay, so now what is the last IP address in each range? 192.168.1. What is the last IP address before we go to 32? It's not a tricky question. 31. 192.168.1. 192.168.1.95, and so on, yeah? We're done when we get to 255 or above. You're done. Okay, does that make sense? Okay, I'm pretty sure you have to watch it again and again. Take a piece of paper, do that, make sure that you're okay with that. In our next lecture, we're going to I'm going to give you 2 or 3 more examples with subnetting, and you can see that you can be asked to answer a question like that on your exam.